Hi, I'm Scott Hanselman. This is another episode of Hanselminutes. Today I'm chatting with Aaed Musa. He's a senior mechanical engineering student at Purdue University. He's got a fantastic website at aedmusa.com. That's AAEDMUSA.com, as well as a really popular YouTube channel. How are you, sir?
I'm doing great. How about you, Scott?
I just love learning about new people building amazing stuff. And I just think that your YouTube is I haven't had so much fun on a person's YouTube since there's a gentleman named Ben Eater who does, you're familiar with Ben Eater and his 6502 project?
Vaguely, yeah.
So he built a microprocessor from parts and just like 7400 series off the shelf parts. And he's like, hey, let's learn about computers. Let's build one. You know, he's the kind of guy who, if you want to make something, he'll like, before we learn about this, let's go find some rocks, infuse them with lightning. And you recently built effectively a Boston Dynamics robot using rope. Surely this was for some senior project or some master's degree thesis. Like you must have gotten a grade for this, right?
No. This is a hobby for me. This is something I do outside of school to rewind.
But aren't you overwhelmed with school? How do you have any spare time? I've got kids in school. I've got a kid who's a sophomore. He has no time to build robots.
Yeah, well, it is, there's a lot of late nights. I'll tell you that. Yeah, I don't really have a lot of free time outside of school and building robots, but I make it work. But yeah, lots of late nights,
Does it directly relate to your degree and your work? Like, are you basically overflowing with enthusiasm for mechanical engineering that even you do your homework, you do your projects, and then you build stuff because you just can't stop making?
Well, I don't really get the building experience in class. I mean, yeah, I'm a mechanical engineering major and, I'm learning all these cool things, but I'm not really applying it in school. So when I go home, that gives me the opportunity to apply it. So for me, it's like a whole world of a difference, learning in school and then going back home and building robots.
Was that disappointing? Did you have this idea that like by senior year at a well-known university, you'd be making stuff?
I wouldn't say I was disappointed. I mean, there are some classes where I am building things, but I mean, for the most part, my entire schedule is just sitting down in lectures and maybe doing labs and, doing recitations and stuff like that. And I understand that you have to, you have to learn things before you go out into industry and build things. So I do understand that there's a lot of learning that goes involved. There's a lot of taking notes that go involved, but I'm a very proactive person, so I like to apply things that I learn like immediately. And, for me, it helps to better stick that knowledge into my head when I like actually go out and apply it.
Somebody said that the way to get an engineer to do something is to tell them it's not possible. It's called nerd sniping. Have you ever heard that term, nerd sniping?
I have not heard that term. That's a great term.
So you tell someone, you could build a robot, I guess, but there's a way to do that. Like we use stepper motors and like this is the way to build robots. And like, you don't do it with rope or, whatever. And then you kind of like nerd snipe them so that they go, I can't get this concept out of my brain. Like I cannot function until I have proven that this is true or not true. And you tell them it's not possible. And then they freeze up and then they run off and they go and they do the thing. Is that how your brain works?
A little bit. Yeah, a little bit. I think I'm fascinated by just really bizarre things. And I think that partially comes from the idea that you can't necessarily do it. So yeah, like a rope driven speed reducer, that seems pretty wacky. And, when you just hear that, if you don't know what it is, you're like, how's that supposed to work? Rope stretches, it doesn't seem like it's possible. But yeah, I think for sure I'm really driven by the idea that things can't be done and no one's really done it or really explored it. So I am challenged by that. And it kind of motivates me to want to go out and prove that it can be done and, prove people wrong.
So we are on an audio-based format, although I might put some of this on TikTok. We may not be able to see the robot. Folks can go and look at Aaed's website. It's listed right there under latest projects, and you can learn about this robot. But help us understand, are there any gears? Are there any stepper motors? Like, what do you use that is traditional in robot design, and what did you use that is non-traditional when building this dog?
Yeah, so the traditional things are the motor. I'm using a brushless motor. brushless motors are really common in robotics. They're really high efficiency, high speed. And with brushless motors, you can use FOC controllers, which are that stands for field oriented control. And so those are just like these really fancy controllers that allow you to have position control, velocity control, and torque control for your motors. And it gives it like this almost springiness. Like you can turn the motor and then it'll spring back to place when you let go. And that's really important for robots, especially legged robots, because it gives compliance and it allows you to like dampen or stiffen the joints of the robot to make it, move in the real world like a actual animal or like a human would. And it gives it a very natural gait and very natural movement. So that's used in robotics, and that's what I used. I used O-Drive FOC controllers. O-Drive is a popular FOC controller brand. What else? No gears. There's no gears at all. So this is a completely rope-driven, I was going to say gearing system, but this is a completely rope-driven speed reducer system. And so it's similar to gears in the sense that you have something driving something else, but there's no teeth. So you can't call it gears. They're called drums. And so if you can imagine, like you have two gears, all right, turning each other, and then you take away the teeth. So now they're just like smooth cylinders. And then yeah, exactly. Like kind of like a pulley, but even pulleys still have teeth, but these have no teeth at all. It's just smooth completely. And instead of teeth, you have rope, and there's like these spiral grooves in the drums to allow the rope to glide around the drums. And the rope is anchored on both sides of one of the drums. And so what happens is when you tension the rope, it allows the drums to drive each other, and they're coupled to each other now in the same way that gears are, except there's just no teeth.
Okay, are they coupled to each other by rope tension? What if the rope slips? I mean, isn't there an implicit lateral friction that is implying gearing at some molecular level? But like if it slips, then you lose precision and you don't know where you are in space.
Mm-hmm. Yeah, so that's a great question. And when you think of a rope-driven speed reducer, that's probably like I guess the first two questions you would think of is A, isn't it going to slip? And then B, well, rope stretches, so aren't you going to lose precision? And both are very valid questions, and both are the things that I had to challenge or that I had to tackle first when I started this project. But no, the rope doesn't slip at all, and that's because of something called the capstand equations. So the cool thing is that if you wrap rope around a drum, you're actually exponentially increasing the amount of friction. That's the amount of friction force between the rope and the drum with every turn of rope you have. So I forget the exact number, but it's possible to like hold the weight of a ship by wrapping enough turns of rope on a drum with just like human level of force. And that's kind of crazy if you think about it, but the math works out. So yeah, there's no slip, and I've designed the drive in a way that the rope is anchored onto both drums to further increase the amount of friction. And yeah, there's just no slip.
This seems like one of those magical things about physics that we all think like that's not intuitive, therefore it must be false. Like levers, right? Like the idea like you make a lever slightly longer and it makes the ability to like have a human powered thing, lever or lever, like flip a car over. It's like, no, that's not possible. So like I'm imagining someone trying to stop those guys on the docks that are trying to stop a ship, and they go and they do the quick couple of loops to put the big giant rope to stop the ship. And it's like, there's some optimal number that you've calculated of the number of turns. 3 is fine. 4 is too many. It's just not necessary. It's overkill. And you figured that out.
Yeah. I mean, you could probably go out and try it at home. If you grab some rope, maybe like a pair of shoelaces, and you find some sort of drum, some sort of cylinder. Maybe it's like, just some sort of cylinder. Wrap it around the drum and see how much friction force you can generate. See if you can pull one end of the rope, and if it slips, you'll find that it's a lot harder to make it slip because of the amount of turns you have on that rope or on that drum.
And that sweet spot, that exponential sweet spot, was where it's like, okay, now I can go and have proportional gearing without gearing.
Exactly. Yeah.
That's crazy. Let me back up and understand like when this started, because you're 22,
21.
21? 21.
Yeah.
You're 21. What's your origin story? Like, when did you have this, like, I must build this? And when did it like overpower what I assume is, as we're kids, I probably shouldn't take apart this perfectly good thing. Like, I don't know about you, but I took apart the toaster. I have no doubt you must have been taking apart the remote control at the house.
Oh yeah. Lots of talking tos that I've got from my parents for taking things apart. Yeah, to put it mildly. But yeah, I've always just really been intrigued with building things. Like as a kid, I was really really into arts and crafts. I remember like the first day I bought my first hot glue gun from Walmart, and I was just hot gluing a bunch of things together. I don't know. I've just always been fascinating with like working with my hands. And I remember like one from my brother's birthday one year, I built him this like Green Lantern suit out of cardboard. I just always really liked building things, and that kind of spiraled into the world of STEM in middle school when I got introduced to 3D printing. And yeah, like you said, I've taken apart a bunch of things in my house. My parents had this laptop this one time, and in my defense, they weren't using it anymore. They had just like set it apart. It was an old laptop, but yeah, I took that apart, and I think I was trying to build a laser.
Okay, you're trying to build a laser with a laptop. How old are you at this point?
Ooh, I think this had to have been, I was probably around 10.
Okay.
Yeah, it's 10 years old.
So this is the thing that I think is so amazing about like young people in this time that we're in. It's like you've effectively been an engineer for like 11 years, like for your entire conscious life, right? I assume you've always been wired this way and you can't remember not thinking like this.
Exactly. Yeah, it's one of those things that's just been totally, ingrained in my every being.
Mm-hmm. Now, why mechanical engineering and not software engineering? It seems like you're doing actually both. I mean, because you wrote all the software for your inventions, you had to write. So you kind of are a full stack engineer, all the way into the design of the physical things. Are you more physical, or are you equally good at software?
Definitely, my skills mostly lie with mechanical design. My software skills, despite appearances, are still, I think, pretty rudimentary. I think I have a long way to go in terms of software skills, but I think, yeah, my real skills lie in mechanical design. And I think mechanical engineering for me is like the mechanical engineers wear all hats, I feel. And if you have a mechanical engineering degree, I think it's easy for you to pivot into several different other engineering disciplines. It's a pretty versatile field, and it's kind of open ended. So you can do a lot with it. And so for me, because I do like all of these aspects of engineering, I felt mechanical would give me the broadest, the broadest knowledge, and give me sort of this vast amount of knowledge in all these different engineering disciplines.
Yeah, I mean, you've got material science, you've got large scale engineering, small scale engineering, tolerances. I mean,
Yeah.
you're also in a world that's different than where I grew up, in that you have 3D printing available to you. So the speed at which you can make this, like how many times have you made this robot until you got it to the point where you call it 1.0?
Well, the actual robot itself, I just made one time, but I started with just a single leg, and that took a couple prototypes. I think I built probably 3 prototypes, but even that isn't the full picture, because just building the actuator itself, that probably took maybe 20 different iterations to get right. So yeah, I kind of start with like the single most unique component in the robot, and really iterate on that. And then as I kind of level up and, okay, I'm going to build a leg and then build the robot, the number of iterations goes down.
Mm-hmm. I'm on your projects website at aedmusa.com/projects, and you're holding this internal cycloidal actuator like it's Tony Stark's heart. Is this the point at which you feel like Tony Stark when you make something like that?
Oh yeah, for sure. I mean, Iron Man is one of my favorite superheroes. So yeah, I definitely take inspiration from him, and just the idea that he just builds really cool things. Yeah, whenever I build a robot, I definitely feel like Tony Stark in his workshop, building his next mark, whatever. And
Yes.
yeah, I get that feeling a lot.
He built this in a cave. Yeah.
With a box of scraps.
With a box of scraps. So
Yeah.
let me ask you this, and this might be a tough question because you're not an absolute expert or a PhD in robots. Are you building robots that are on the cutting edge of like hobbyist robots, or are these on the cutting edge of robots in general? How do you know if you're designing a thing that someone else has already designed and maybe you should just buy a part versus I'm going to make my own actuator, I'm going to make my own leg? You know what I'm saying? Like, I don't know
Mhm.
what the cutting edge of robots is. I assume it's Boston Dynamics. Are they
Yeah.
just basically a bunch of guys like you with like fancier printers?
Yeah, exactly. I think that's the great way to put it. Yeah, if Boston Dynamics is like, a bunch of guys like me who are just really passionate about this stuff, but with industrial level equipment and just out of this world manufacturing capabilities. And, a lot of guys who are much, much smarter than me and are much, much more into like the niches of engineering, into the software and electrical engineering. And yeah, when you bring a group of guys like that, you can make incredible robots. But yeah, I think for me, the robots I make, they could be made by by Boston Dynamics 100%. But yeah, I think it's more for the hobbyists, showing what you can do at home. I think for me, that's what the real appeal is for my videos. It's showing that, yeah, Boston Dynamics is really cool, and that stuff seems like kind of out of this world, but you can do something similar, at home in your apartment. And for me, that's what my robots are about.
So you're printing actuators and drives. When do you draw the line between like this is good enough, it's plastic versus I need metal? Like what's the threshold where it's like I need to stop and I need to buy something and have it shipped here
Yeah.
versus just getting an M3 screw that you found and you've got a pile of them from Alibaba?
Yeah. That's always a hard thing to figure out. And there's no real good answer other than I test things. And if it's not good enough, then I'll go out and buy the actual thing. And it also just depends on like, okay, what's the scope of this project? If I'm building a robot, if the goal is to make it as cheap as possible, then maybe I'll 3D print everything. If the goal is to just get it to work because I really like the idea of this robot, then maybe I'll just go out and buy actuators. So yeah, it's a couple of different things, but I definitely say the intention of the project going in. Do I want this to be something that I know everyone can make and something that is just completely DIY, something that can just be completely 3D printed? And also things like, how much time do I really want to invest in making my own actuator? That can take months to get right. If I can just go out and buy one, that's going to be a lot faster, a lot easier for me. So it's a lot of things that I balance in my head. But yeah,
And still you make your own actuator.
yeah, yeah. I mean, the Capstand Drive one wasn't horrible. It wasn't too bad. It took a lot of testing, but I think it was one of those projects where the intention was to design an actuator from scratch.
Mm-hmm.
So yeah, going in, I knew that was the goal of the project.
Mm-hmm. And like I'm looking at, it's called Cara, Cara, which is
Yeah.
Cara, your latest robot. Is that something I can go to your Patreon and download and like make myself, or is that something you haven't quite packaged up yet for me to try to reproduce?
Yeah, it's not quite packaged up yet. There's like no documentation at all on how to build it. But right now, I am working on a mini version of Kara that is going to be ridiculously cheap for a robot, that is. But yeah, I'm working on a mini version of Kara that is going to be open source and something that people can make at home. But that's going to be a lot better than this version, and it's going to still have capstand drives and all, but it's going to be a lot cheaper.
Oh wow, that's cool. My buddy Mark and I, for a thing over at Microsoft, borrowed a $25,000 robot from Hello Robot, and it's like an open source robot platform. It's like a Roomba with a giant arm, and it can
Mhm.
open doors and do kind of stuff. But we were really surprised at like there's the mechanical aspect of robots, which seems to be very advanced right now, but then the getting them to do stuff and see the space around them is kind of a mess. Like
Yeah.
it just spends a lot of time scanning and looking around. Is Kara blind, or can Kara see stuff? And or is that another different wall that you have to climb over?
Oh yeah, Kara is completely blind. I mean, she has googly eyes, so maybe not that blind, but in terms of computer vision, there's really none. Um, I have an IMU on Kara just for a bit of stability, but everything else it's just teleoperated. But yeah, the goal in the future is with Kara Mini and just regular Kara in general is to add more vision and more autonomous capabilities.
Hmm. You said an IMU, that's an inertial measurement unit. Can you talk about why that is
Yes.
important in robotics?
Oh yeah, for sure. I mean, if picture a robot that you build, if it's going out into the world, there's so many unknowns. If the robot is walking up a hill, for example, how do you compensate and ensure that the robot's not going to tip over and fall? If the robot steps on a rock or something that is not part of the flat ground, how do you ensure that the robot stays stable? So an IMU, like you said, inertial measurement unit, it's a sensor that essentially measures tilt in all three axes. So if the robot tilts in a certain way, you can measure that tilt and to a pretty high precision, depending on the IMU that you get. But you can measure that tilt and compensate for it.
Okay, and IMUs can be collections of sensors, right? They can be
Yes.
accelerometers, gyroscopes, magnetometers.
Mm-hmm.
And the idea is not to see where it is, but it's more like, I think it's called proprioception. When humans can put their feet on the ground and kind of tell if the earth is moving or if they're moving, that those
Yeah,
kind of
exactly like
questions can
that.
be answered, right?
Yeah.
Interesting. Is computer vision a space that you'd be interested in getting involved in, or would you, if you were going to give Kara eyes and let her walk around and do stuff, would you? Is that a different discipline, and you'd get a team member to help out with that?
So yeah, I didn't mention this, but Kara Mini is actually going to be my senior design project.
Oh wow!
So
Congratulations.
yeah, yeah. So I'm going to be working with a couple other people on making it happen, and I haven't fully built my team yet, but we are planning on getting like people who are outside of my discipline, outside of like the really mechanical, the mechanical part of the robot. And so yeah, the hope is to get people who are more software literate and can help with the computer vision.
That's going to be huge. And you're a senior this year, so this is going to be like a year out, like a year from now. There should hopefully be a bunch of Kara Minis running around causing trouble.
Well, yeah, I'm actually this is my last semester, so hopefully
Oh,
by
your
like
last semester,
December we
you're
should
that
have.
close? Oh my God. I thought I
Yeah,
didn't, you're accelerated. I didn't realize. I thought you'd be going out into May or June next year.
yeah, I'm graduating a semester early just because AP classes and taking a bunch of summer classes.
That is amazing. I hope I'm going to make sure that my son watches this episode and appreciates the overachiever, because I'm trying to tell him you got to take the AP stuff, you got to do summer classes. That's going to save you so much time. Which I assume then means you'll start your master's degree earlier and then bang
Yeah,
that out in a year instead of 2 or 3.
yeah, exactly.
That's fantastic. Do you think you'll go and become a roboticist, or will you go and make bridges? Like, what's your dream job?
uh my dream job, ideally, yeah, I'd be making robots every single day. I'd be working on making robots all the time. That would be my dream job. Where that fits in is a little harder to answer. Going into industry, that's one option. That's a great option. I'm interning right now. I like building products. It's nice to have industrial equipment at my disposal, things that I can't really do at home. But then also, doing the content creation full time, I can also build robots all day doing that. And so I think we'll see where the future lies. And in a year, I'll kind of gauge where my channel is and really make that decision then. But
Mm-hmm.
yeah, to answer your question simply, I just want to build robots all day.
No, I mentioned that you've got a Patreon. I realize that that's not the goal. Like, the goal of that is, I assume, to pay for school. But like, is your goal to become like a full-time creator and make robots and work for yourself, or would you rather work in a team at a big company or at a Boston Dynamics?
Yeah, I think for me, the goal would definitely be to do the content creation thing full time. But even more than that is to like have my own startup and start a company in conjunction to the content creation thing, because I feel like those go hand in hand. So yeah, for sure, I think the goal would be to sort of be my own boss and to have full creative liberty.
Mm-hmm. And help me understand what your lab looks like. I thought I saw a bamboo printer over there. Like, what are you building? What is you're Tony Stark, you're in a cave, you're building with scraps. What are your scraps? What are your tools?
Oh yeah, very scrappy. I mean, it's just my apartment. So I have three different Bamboo Lab printers. I have the A1, the
Hmm.
A1 Mini, and the X1 Carbon. And if you don't know, Bamboo Lab, awesome printers. They're super fast. I totally recommend them. And I don't just say that because they've sponsored my video, but like they genuinely are, I think, the at the forefront of FDM printing right now, and their printers are super affordable. But yeah, my printers are like my main manufacturing method. I have an Elegoo Saturn V SLA printer,
Hmm.
and it's okay. It's all right. I don't do a ton of SLA printing just because FDM is just so much faster, and I can crank out parts in a fraction of the time that I can with the SLA printer. But yeah, I have just regular tools, wrench, screwdriver, all of that. But yeah, I'd say my bamboos are my biggest or my most high tech tool.
Yeah, I've got a P1S. So when you listed out A1,
Mm,
A1 Mini, and then you leapt over them to the A1, the X1 Carbon, rather, that is an amazing. I aspire to have a Carbon at one point, but I've got a highly modded P1S, and it is the iPhone of printers. Like
yeah,
everyone understands that when you start 3D printing, you spend most of your time printing stuff for your printer. Like you're not actually making anything; you're just modding the printer, and
yeah,
then I would spend probably the first 10 years of 3D printing was just trying to get the first layer right.
mm,
But what's great about Bamboo Labs is that you stop messing around with printing and you just start printing.
yeah,
It has a really long warm up, that first layer, like it double checks everything, spend 5 minutes. And then for that 5 minute upfront cost, I don't think I've had a failed print in memory. So
yeah.
now you get to be a mechanical engineer and not a 3D printer messer arounder.
Exactly. Yeah, yeah. It's so cool. I mean, I think I forgot who said this, but I think the best way to capture Bamboo Lab is their goal is to not make 3D printing necessarily a hobby, but it's just they're making it another tool for you. So you're not becoming a 3D printing hobbyist necessarily when you get a Bamboo Lab printer because you're not trying to figure out the best settings in your slicing software. You're not, figuring out the best nozzle size or stuff like that. You're just using it as another tool, like as a wrench in your workspace. You're not tuning your wrench every day to figure out the best way to use it. You're just using it, and I think Bamboo is doing that with their printers.
Yeah, absolutely. They're not a sponsor of mine, but I tell people at any turn, anytime, buy an A1 Mini if you want to get started. They're an
Yeah.
absolute delight. And then you said FDM, fused deposition modeling. This is of course what they call additive printing, right? I
Yes.
describe it as like drawing happy birthday on a cake with liquid sugar, except you're
Hmm.
drawing on a board with liquid plastic, and it is a delight.
Yeah.
Yeah, and I'm looking at some of your models, and like they're so clean. Like Kara does not look 3D printed. It's colorful, but like you
Thank you.
can't see the layer lines. And the Capstand Drive, I mean, they're great prints.
I appreciate that. That's all due to the Bamboo Lab printers. I can't take credit for that.
And what do you model in? What tool do you use for modeling? I'm a Tinkercad person, but I'm not very
Yeah.
sophisticated.
I use Autodesk Inventor.
Oh, really? So you're doing that? Did you learn that? Did you teach yourself that, or is that taught in mechanical engineering school?
I learned that on my own, and also I started learning it on my own, and then I joined a FRC team, first robotics competition, and I had a mentor that really taught me like the ropes and how to really design things well. So it was a little bit of both, but definitely a lot of help from mentors.
I need to go and dig around on your YouTube, and I don't know if you've done any tutorials on that, but like when those situations where something breaks and you got to grab the calipers and then like, do I make this or do I buy one? Or you end up
Mm,
on a website trying to like, I've tried to print gears because sometimes I'll find a toy at Goodwill and it's got a broken gear, and I'm like, all right, I'm going to 3D print a replacement gear for this, and I bust out the calipers and try to do it. It'd be interesting to see even a time lapse of you designing something in Autodesk Inventor. Just
yeah,
a request from a fan.
yeah, I'll take that to heart. I usually in my videos the CAD. I'll do like a 2 second brush by of okay, this is what it
Too
looks like in
much,
CAD.
too
On
fast.
to the next thing. Yeah, yeah, for sure. I think that'd be cool to actually like show my design process.
Yeah, I think it would be because what what is so exciting about these things, I mean, you've definitely got the YouTube dialed in. Like they're about 20 minutes long. They're well edited, well designed. They get great views, but they just make you feel like, I could probably do this. It gives me the kind of false confidence that I think every good YouTuber should give someone. I don't have your ability, but I admire it, and I appreciate you spending time with me today.
I appreciate that. And yeah, that's the goal. I hope that people can watch my videos and get inspired and go out and build their own thing. Cause that's the same way I feel, that I've gotten inspired by a lot of different YouTubers that I watch. And that's in part, what motivated me to start my own channel, to go out and build things. It's, I think you do need a little bit of overconfidence and just a little bit of, a little bit of bravado to go out and build things. And I think I can help people achieve that through my videos.
I appreciate that. Thank you so much, Aaed Musa, for spending time with me today. He is a senior mechanical engineering student at Purdue University. You can check out his website at aedmusa.com. That's AAEDMUSA.com. We'll put that link in the show notes. You can check out his YouTube channel and explore his projects. This has been another episode of Hanselminutes, and we'll see you again next week.